Hello, everyone, and welcome to a free data analytics workshop, storytelling with data. So, thank you first of all, thank you very much for giving us your precious time on a Tuesday afternoon / evening. We have a lot of fun stuff prepared for all of you. And if you have never coded before, or if you have coded before, or you have never done any data analytics, then tonight is going to be your first taste of both of those, or either or. With me, so my name is Ramon, and I am the data science educator at Coder Academy, and I create courses here in data analytics to try to help people upskill into what is this brand new field, or not brand new field, but this field where we make use and make sense and make use of data. So with me tonight, I have two awesome people. One of them is Goran, and another one of them is Dallas. They are our course advisors, and they're going to be with us throughout the entire evening. Now, what are we going to do? What is this evening going to look? So, sorry, Goran and Dallas, would you guys like to say hi to everyone and introduce
Hello.
Hello, everyone.
Hey, so yeah, basically, Ramon's going to run the show, and then we'll have a bit of a chat with you later on, and just to sort of discuss the finer details of what's involved to, get started with our data short course starting on the 31st of October. So essentially, as we're progressing through, maybe try and hold off on some of the questions you have for the course to ask at the end or during the presentation we put on afterwards, just to sort of leave space in the chat for for the free data workshop that's going to be happening tonight.
Awesome. Perfect. All right. So yes, if you have any questions, throw them in the chat. Also throughout the presentation and throughout the program, if you have any questions, please toss them my way. I'm going to do my best. I'm going to have the chat right next to me, and I'm going to try to keep an eye on it to answer any questions that come along. So now, what are we going to do for tonight? What is tonight going to look like? Let's move on to that. So I'm going to grab a link, and I'm going to paste it in the chat. And I want everyone to go to this link that I just pasted on the chat. In that link, you're going to come to this website. And in that website, you're going to go to the very bottom where it says, click below to access a live environment and start coding. And this is where we're all going to go. So you're going to click on that button. It's going to take a minute. Give it a minute until it starts. It's going to give you a preview of where we're going to go. It's going to say a bunch of stuff. Don't worry about it. It's just starting up a little container that has the code and the platform we're going to use tonight to code. And you can start scrolling over here and look at the lesson for tonight. There's a lot of fun stuff prepared for you. So yeah, that's where we're going to go. So like I said, it's going to take a second for it to start, but once it starts, it's going to take you to a place that's going to look just like this one. And it's going to say, welcome to data visualization in Python. This is going to be the lesson that we're going to go over tonight. We're going to talk about quite a few topics. As a matter of fact, let me talk about the outline for tonight. Let me zoom in a bit. That should be good enough. So actually, let me do one more just in case. So tonight, what are we going to cover? We're going to talk about, we're going to do a quick introduction to data visualization. We're going to talk about what data visualization is, what is quantitative versus qualitative data visualization. The schema, we're going to go over the schema for creating visualizations. When you have data that is, say, prices of all of the foods and all of the items that you purchased at a supermarket when you went for your last grocery shopping, well, that is a quantitative number. That is a quantitative data point, or those are quantitative data points. When you have things such as hot, medium, cold, or gender, female, male, others, you have a qualitative variable. So we're going to talk about what those are and how do they make sense in data visualization. We're going to talk about the differences between static and interactive visualization. And then we're going to go over the do's and don'ts. The don'ts are the really funny ones. But the do's are just those rules of thumbs that you should pay attention to and know about when you are doing data visualization. Then we're going to do a quick flash introduction to Python and to Jupyter Lab. Jupyter Lab and Jupyter Notebook is what we're going to be using to code in tonight. This is also considered a integrated development environment. What is an integrated development environment? It is to programming what a kitchen is to cooking. So to cook, most of the times, if not all of the time, or most of the time really, you cook at a kitchen and you have knives, you have forks, you have plates, you have glasses, you have everything you need, all of the tools that you need to make a meal. In an integrated development environment, you have all of the tools you need to do some programming. And that's exactly what we're gonna look like, what we're gonna do, or where we're gonna code in tonight. Then we're gonna talk about our project for the evening, or what we're gonna work on. Then we're gonna talk about the data we're gonna use. Then we're gonna start interrogating the data, one data visualization at a time. Then I'm going to give you some next steps if you want to get started in the field of data visualization and data analytics in general. Has everyone, if you have not been able to open up, yeah, this is going to take a few minutes, but if you have not been able to open this up yet, let me know. And if it already opened for you, then great. I'm going to leave mine there as it should be almost done. Pushing image. Bear with me for just a second. The beauty of live coding. Okay, so it's launching now.
Mine is launching.
I know it's taking a minute. Okay, I just refreshed that. So if yours has not launching server, okay, it's probably coming up. I'm on the same pushing image section. All right. So what we're going to do is we're going to give it, we won't be coding until about 20 minutes from now. So you can click on the refresh button. I just refreshed the repository that holds this tutorial. So what you can do is you can go back to this page, to the one that I link you, stay there for about 20 minutes, since we're not going to be coding for the next 20 minutes. And then in 20 minutes, we all open it up. Okay. So, all right, let's get started with the explanation and with the baseline, or an introduction to data visualization, and then we go back and open up the repository. All right, so what is data visualization? So here's a definition that I really like, and it is by Tableau. First of all, let me ask in the chat, who here has created a data visualization before, whether in Excel, whether in Tableau, Power BI, in any kind of tool? Who here has created a data visualization before? Or actually, let me step back. I'm on the same pushing. Okay, no problem. So who here has coded before? Let me start with that question. If you have coded before, if you have written a line of code, I would like you to put yes in the chat. Okay, awesome. We have quite a few people. If you have not, put no, I have not coded, because we want to see both. Okay, awesome. So we have quite a few of you that have never coded before, and quite a few of you that have coded before. Okay, awesome. So how about this? How many of you, or which ones of you, if you have created a data visualization before, for those of you that have coded, And those of you who have never coded, if you have created a data visualization before, either in Excel or in any kind of tool, even a handwritten one, you draw one, I want you to put me or yes. And if you have not, put no. Okay, quite a few, and even a person with Excel, another one with Python. Awesome, awesome. All right, so this is good to know. We have a good mix in the crowd of people that have and people that have not done any data visualization before. So that's great. All right, so today, here is, now let's get started. So now that I know like a little bit of the background of everyone, some of you have coded, some of you have not coded, some of you have created data visualizations, some of you have not. Let's talk about what data visualization is. So data visualization is a graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in the data. Let's disentangle that. So can anybody in the chat tell me what a picture is? What is a picture composed of? What are the elements that make up a picture? Any kind of picture, say the image that you're seeing right now. If an image were to be taken of me, what would be this image composed of? Graphics, colors, yes, pixels, awesome. So pixels is the right word. So pixels, so an image is a combination of pixels. And a pixel is a combination of three things, or most of the times three things. And those three things are RGB. RGB stands for red, blue, and green. Red, blue, and green are three numerical values that compose a piece of color. The combination or the multiplication of those three colors make up a layer. That layer, or that little square, is a pixel. Many of those pixels are a graphic or a visualization or a picture. Now that we know what a picture is, let's talk about what a data visualization is. We have data, that is one layer of it. Then we have the representation of the data, that is another layer for it. Then aside from the representation of the data, we also have the encoding. So we have data, say information of items that we purchase at the supermarket. Then we have a representation of that data. Maybe we want points, maybe we want a line. Most of you have probably seen a line before. Most of you have probably seen, aside from a line, you've seen points, or you've seen a scatter plot, or you've seen bar charts in the news, in newspapers, and anything. And then the next thing is, okay, now I have my data. Now I have the representation that I want, but how do I encode those things? How do I encode the data to the representation I want to show my audience or myself if I'm doing data visualization for my own purposes, for my own intensive purposes? So those are the layers. Just like a picture has layers of pixels of red, blue, and green colors, a data visualization has layers. It has the data, it has the mapping or the marking, the thing that we want to use to represent it, and it has an encoding from that thing we want to use to represent the data to the data. And that's what we're going to untangle in tonight's lesson. So Python has a bunch of tools, or a lot of tools, to make it easier for us to showcase visualizations of data, containing data. Some of them abstract the way in which we can visualize things more than others. And the one we're going to use today allows us to build things on top of one another. So just the three layers that I explained today, that's exactly the core idea I want you to walk away from. I want you to walk away with tonight. A data visualization is a representation of three layers of things. One is the data, one is the type of marking that we want to use to represent the data, and another is the encoding. I want you to walk away with that. And I want you to, anytime you analyze the data visualization later on, when you walk outside and you see something in a billboard or in the news, and you see a chart, a graph, think about the components that make up a chart and think about how they created that chart. And then you can start criticizing or acknowledging the good things and the bad things that a chart might have. And we're going to talk about what those two things are, the goods and the bads of data visualization. All right, so there's quite a lot of libraries in Python. When we get to open this tutorial, you will see that there are several ways or several libraries here that you can use to code in Python data visualizations. We're going to use specifically the one called Altair tonight. In Altair, oh, actually, this one goes somewhere else. So that is not the link. Let's go to Altair straight. So here's how to tell. It's a declarative visualization library in Python. It is built on top of another programming language, so it has Python wrapping fancy things across it. And this is the visualization, the tool that we're going to use in Python now. All right, so let's continue. So now that we know what data visualization is, a representation of information placed either in a two-dimensional space. Sometimes data visualization also comes in three-dimensional space, but we only care about the ones in 2 dimensions. We started talking about pictures, what composes a picture, and what composes a data visualization. Now, what is the difference? What kinds of data visualizations are there? Or what kind of information can we visualize? Well, there's 2 main kinds of information and data that we can visualize. The 2 of these are quantitative versus qualitative. Quantitative is the same one that I described a second ago. And actually, we have a nice table here. I'm going to zoom out just a bit so that we can see the table. And this table is taken out of a fantastic book called Fundamentals of Data Visualization, a primary information concept of creating data visualizations. All right, so let's talk about quantitative and qualitative. So quantitative are numerical and continuous variables or continuous information. Think about when you open up an Excel workbook, or when you open up a or when you get a piece of paper, and in that piece of paper you create a column. In that column you start writing down list of things that you need to get. I need to get 2 cases of eggs. When I go to the supermarket, I need to get 1 gallon of milk. I need to get cereal, I need to get things. So you put the quantity on one side, and then on the other side, you put the item, the name of the item. The name of the item might be a qualitative variable or a qualitative piece of information, something that cannot be necessarily, that doesn't represent a numerical value like 1.5, 3, 7, 10.99, 5.99, as you often see prices in the supermarket. And not even in the supermarket, anywhere you go really. If you go and try to buy a pair of shoes, chances are you'll see them at, I don't know, $79.99, $69.99. Any continuous or numerical representation of information is considered a quantitative piece of information. Qualitative piece of, so also numbers without a decimal place, such as integers, 1, 2, 3, 4, they are also considered quantitative information. Now, qualitative or categorical, these are things that are put into two kinds of buckets. One is on order such as dog, cat, fish, male, females, chair, table, and anything you can think of that doesn't need to be counted but can be separated into yes or no. Well, actually, even yes or no, or true and false. That is a qualitative piece of information. Now, qualitative order information, good, fair, poor, as it is described here. Another good one is if you think about the positions in that motor, the car races, in car races, first, second, third, last place. Those are things that have clearly an order. The first place didn't come after the last place. So these are things that have order. So that is the second type of a qualitative piece of information. All right, then we have date or time. Date or time can be represented as actually the name of the month, the name of the day, the name of the year, the hour, the minutes, the seconds, the milliseconds, the microseconds, and the macroseconds. And this is considered time. A lot of information out there, or a lot of analysis that we see on a daily basis, depend heavily on the date data type. So let me give you an example. Weather, stock prices. So a stock, the price of a stock that at the closing time today in the Australian Stock Exchange or Sydney Stock Exchange, I forgot the name of the stock exchange here, it's not going to be the same as the price at which it opened today. It is most likely going to differ either by just a few decimal places or by quite a few dollars. So that is a representation of time. The weather that we had yesterday is probably not going to be the exact same weather we're going to have today. If you see that the temperature was 18.7, it's probably not going to be 18.75. Today it's probably going to be 18.8, 18.9, although it could be. But that is a type of representation that depends on time. All right, so The last one is text. Text is kind of is what is considered unstructured data. So when you look at this table right here, this table is actually represented in a very structured way. If you think about the tables that you see in Excel or in any kind of newspaper outlet or article on the internet, you see a column, you see some information underneath the column, and then you see other columns, and you see information mapping on the rows. We immediately look at the rows, and we know that a row is goes together with every item in that row. And then we know that every item in that column, in a column, is going to be of the same kind. So the ones in the rows will differ, but the ones in the columns won't. So think about, for example, here, the description. They are all bits and pieces or paragraphs and sentences that describe what the first column is saying, but they don't contain the same information as the same column. So everything in a row changes, everything in a column doesn't. Now, unstructured data is, for example, a menu at a restaurant that you find online. So if you find a restaurant online and you go to the menu, well, that menu has a ton of unstructured data. What is unstructured data? And depending on how fancy the menu might be, so you will find some items on one side, and then the prices all kind of like in different places, organized so that it is appealing to the human eye, but that is also aesthetically pleasing for the shape and outline of the menu. So that is unstructured data. Another type of unstructured data is an email. And all of these are things that can be visualized. All right. So now let's talk about two different things. So static versus interactive data visualization. So the main difference between the two is, what do you want to accomplish with your data visualization? Do you want to tell a story and you don't want anyone to see anything else besides that story that you want to tell? Or do you want to allow the user of your data visualization, or yourself for that matter, to change the story of the representation of the data that you have as you go? If the answer is the latter, then you're probably most likely going to use an interactive data visualization. If the answer is the former, then you're probably going to use a static data visualization. You want to give somebody a piece of information and you want to throw it out at them at that point in time. All right, so those are the two main different things of data visualization. Sorry, the two main kinds of representations or questions that you want to ask yourself. What kind of information do I have? Do I have quantitative or qualitative or both? What kind of charts do I want to make? Or how do I want my user to interact with my chart? Do I want them to see a specific type of information at a specific point in time? Or do I want them to change the story that I'm telling them as they see fit? So those are very important things to keep in mind. Now, the do's, let me zoom in a little bit. Now, the do's and don'ts of data visualization. So when creating data visualizations, you have to keep in mind that labels are important. If you have an axis, say a Y and an X axis, and you don't label what the axis is trying to show, then you might mislead, or not necessarily mislead, but you might not give your users or yourself enough information. Well, maybe yourself because you are the creator of the chart. But if you're going to share that visualization and it doesn't have a label for the axis, or a label for the title, then it's going to take some time for them to dig into that visualization and really find out or figure out what is happening in it. Add a title to it. You need to add titles. Every visualization should have a title, unless it's so obvious what it's trying to show. Or if you are creating the visualization just for yourself because you are interacting with the data and you are exploring data, then you don't need to worry about what you put into the title or into the label in the axis, because it is just for you. Now, use color appropriately. Showcase what you need, not every data point. Another thing is use full axis to maintain consistency. So for example, if you ever look at a chart, at a bar chart that says taxes went up this year from X percentage to X percentage to this side of the population, to the middle class, to the upper class, to the lower class, or whatever. And the axis doesn't start at 0, the origin of the axis of where the axis crosses is not 0, then they're most likely trying to deceive you. And I'm going to show you an example of that here in a second. Now, ask others for opinion when you create a data visualization. Why should you ask for others' opinion? Well, the main reason is because you want to get feedback on your work. You want to be told what could be better, or what was really good and you should keep doing, and what was not good and you shouldn't keep doing. And those are things that help as a data analyst, as a data visualization designer, as a graphic designer. You want feedback on your work to be better. The squinky or blurry test is when you get far away from a visualization and you cannot see the colors or the representation because it seems blurry. It means that the pixel or the way in which you saved the image wasn't good enough or wasn't of high quality. So for a lot of people, they might not be able to see it, especially me. Like I use glasses. It has to be like I gotta see it, a big visualization. All right. So those are some of the main do's for data visualization. Now let's have some fun looking at the don'ts. So in the very first one, I have don't use too much color. But can anybody tell me what else is wrong with this data visualization? What else do you think is not good of this data visualization? Small labels, yes. Too many options. Contrast, absolutely. So it's the contrast, the labels are too small. As a matter of fact, it's not even, so I don't even know if maybe, so one thing that you might notice immediately is that, yes, maybe it is sorted by which state has had the highest growth in the US, population growth between 2000 and 2010. But maybe, you know, as soon as the user, as soon as you go, oh, you want to see it sorted by alphabetically, as opposed to the numerical value that had the most or that had the largest amount. So it's very tricky to figure this one out. But yeah, those are good. Those are very good observations. No legend. That is very good. All right. So the next one. Don't use unmatching percentages. I know this seems like it is very logical, but if you came to our industry event about a week and a half ago or 2 weeks ago, then you would have heard one of our speakers mention common sense is not common. So charts like this appear all the time where you see unmatching percentages in a chart that is trying to tell you something very, very informative or very important. So don't use unmatching percentages. Yeah, there's a lot. There's definitely not 100% here. There's way more. All right, and I mean, look at this: leaders, willing to learn, tech savvy, people savvy, creative, whatever all of that means. Don't try to put everything in a graph. I mean, it is absolutely impossible to even be able to tell what's going on here. As a matter of fact, even if you were to click on one, what's going to tell you that you're looking at the right color? Some of the colors, they look exactly the same. So this is not even a useful pie chart. I mean, this is not, that was time wasted right there for whoever, whatever analyst made that or whoever made that. It looks like a CD. That is awesome. Don't go towards the light. Yeah. Wow, it looks like a CD. I love that. So this is very important, this next one. And it's absolutely crucial to get it right because a lot of people, so it can be very deceiving. When you have trend lines should be used to represent time. Every time we look at a trend line, we think of a y-axis, we think of an x-axis, and we think of a line going up. And then what do we always see in the x-axis? We always see time. We see years, we see months, we see weeks, we see days, we see hours, but we don't see categorical variables. Here we have, what is it? Poker, blackjack, bridge, gin, cribbage, hearts, canasta, peanut, whatever all that is. I can't even pronounce some of them. Spades. So essentially, it's giving you the impression that the value at each one of those categories is increasing over time. So the first thing that you see when you see a line, you think of time, but then there's no time here. So that is a deceiving representation of information, of visualization. And actually, there's a link to all of these charts, and they won the worst visualizations of all time, some of these ones. So don't make your charts unreadable. So we saw I'm not a big fan of pie charts. As a matter of fact, I never use pie charts, but I have two in this set of don'ts, and this is probably one of the ugliest ones that I've ever seen. I mean, not only do you have a representation that you could have had in a different way, I mean, I think honestly that you could have put all of this information in a table, and then with the numerical value that you're trying to represent as the proportion of 100 on another column, and then you would have a very beautiful table as opposed to a pie chart that doesn't even make any sense. 3D pie chart. I know. It's a 3D pie chart. So in this one, I wrote this on purpose. Don't make no sense. I didn't even attempt to understand what was happening in this one. I just know that I couldn't. And that my little brain was really hurting from trying to capture what was going on here. There's a lot of stuff. Can anybody have a guess at this one as to what might be happening? What might be happening here? It aims to confuse. I think that is that is the best description of this. It is actually aiming to confuse the user. The government stealing in plain sight. it could very well be the government stealing in plain sight. So this is, let's go to the next one. Don't deceive your audience with different intervals and axes. So this is very, very important. If you are going to show a line trend using date in your x-axis, think about high school math. Think about those XY coordinates. In those XY coordinates, your professor will always tell you, put the 0 where the y-axis and the x-axis will cross with each other. So you will put the 0 there, and whatever you're plotting, you know that the right side from the x is positive. You know that up is positive. You know that down is negative, and you know that left is negative. So if you're putting something on the right side, because there's a positive value. Say here we have 7 millions, 9 millions, 13.5 millions, 15 millions, and whatnot. Well, look at this, December of 2007 to September of 2008. So it's not even going in the same interval. It's showing the interval that they want to show. It could be that in December of 2008, it was 7 millions again, and it just went up to 9. And it made more sense for their agenda to show September 08. But then look at that. Then it goes to March of 2009, because probably that fit their agenda as well. Then it goes to June of 2010. I mean, what is going on here? Who on earth made this? Of course, it's Fox News, which has a very right-wing agenda. So, and if this is December to June of 2010, this was during Obama's time. So, I mean, I would assume they're trying to show something with this. But anyways, okay, access betrayal. Do not betray your audience. So if we were to tell our audience, there has been a huge increase on border apprehensions from October to April. October to April what? And then it says here 2011, then 2012, and 2013. But the fact is that this is not starting at 0. The axes are betraying us. Remember, the y-axis, the x-axis, the origin starts at 0 when those two cross. This is what your professor told you a lot about in high school, or maybe in elementary school when you first took your basic geometry. So start at 0. If this chart was at 0, it will probably be so meaningless, the difference in between those three, that you couldn't even be able to tell. At least for sure for the 165,000 to 170,000, maybe a bit of a bump between 165 to 192, but that is access betrayal. Fox News, fake news, somebody said. I love that. Okay, so those are the sources there. Now we're going to talk a little bit about Jupyter. So let's see if you click on here in the link that I sent you, I think Dallas just put it back on there, the link. When you go to this website, you should click on this button right down here, which says Launch Binder. And then it's going to start launching up the same thing that I have right here, the same representation. So let's see, it says that it's starting up the repository. So we're going to give it a second. Yep, now it should be working. So if you get to Binder, please type I am in Binder, or just put Binder for sure. Awesome, awesome, awesome. We're about to get started coding. So let me explain what this is so that you don't get confused if you get locked out of Binder. So Binder is a free computational power. So it's like a mini computer that is given to people for free because the resources cost money to whoever is providing Binder for free. And I forgot the organization. If you are not using it, it locks you out after 10 minutes or 15 minutes, I believe. So if it locks you out, it's no problem. Just go back to it. Just go back to the repository, click on Binder again, and it will spin up again, okay? So yeah, don't panic if it goes away, if it tells you, hey, you have been locked out because of not using it. It usually takes 10 minutes before it tells you, it gives you that. But once we get started coding, no 10 minutes will have passed without us clicking on something. So, all right, so let's go back to it. So let's talk about Jupyter Lab. So I mentioned that Jupyter Lab, what I am using right now in Jupyter Notebook is this document that we are using. This document allows you to write text, it allows you to write, and it allows you to write code. So basically the best of both worlds. You can combine prose and code. And so Jupyter Lab is what is called an integrated development environment. And I mentioned earlier that an integrated development environment, it is to a programming language what a kitchen is to a chef, and or to us for cooking. For a cook, it's a place where you can write code, test applications, test data analysis, create data visualizations, and in our case, share narratives with people. Notebooks are becoming very, very popular, not only in the data analytics space, but also in different kinds of arenas, because it allows you to test code interactively. And we're gonna learn a little bit about that. So a couple of key things to keep in mind. Actually, let me go, since everybody has the same view in Binder, I'm going to switch to Binder. Let me scroll up a little bit. I'll actually zoom in a little bit, sorry. Perfect. Okay, so here are some of the most important things you need to know about Jupyter. So Shift Enter allows you to run code in a cell. Alt Enter allows you to run code and insert a new cell below. What does this look like? So if you have a blue line in this tab, you don't need to, if you double click it, you're gonna go into the tab, and you don't want to do that. I mean, it doesn't really matter, but you don't want to go into the tab. If you go into the tab that has written words, you can press Shift Enter and it will go back to the same view we had. Now, let's work. So let's talk before we continue, and I show you Alt Enter and everything else. Let's talk about Python. So why Python nowadays? Why are people actually? I mentioned who has programmed, and I mentioned who has done some data visualization. Who here has used Python before? Say yes if you have. Say no if you haven't. Okay, quite a few of you. Quite a few of you have not used it. Some of you have used it. Okay, awesome, awesome, awesome. All right, so let's talk about what Python is. So Python is a general purpose programming language. What does that mean? That means that you can build websites, you can build the engine of a website. So the engine of a website is what is referred to as the back end of a website. It's what processes everything that happens inside the website. So inside the website or in front of the website, we have something that is interacting with the user, what is called a user interface. So when you go to bbc.com, or when you go to the Sydney Herald or whatever, and you're interacting with a user interface. Behind that user interface, there is an engine or the back end of a website taking in data, taking in your clicks, putting up the ads, putting up the content, putting up this, putting up that. Then the front end, the user interface, is what interacts with us and what front end developers prettify and make really fancy. So Python allows you to create the back end of a website. It also allows you to create the front end, but you probably want to use something different for that to prettify it. It allows you to create applications. It allows you to create games. And most importantly nowadays, personal opinion, it allows you to do data analytics and data science. And we can talk a little bit more about the difference in between the two, data science and data analytics. But essentially, Python is a Swiss Army knife, except that it is Dutch, because it was created by a Dutch guy. But nowadays, I mean, it's a very international language. So Python, I have an analogy here that Python can be thought of as a person. We are very cool the way we are and the way we interact, but the way we interact with people more efficiently, or maybe we communicate better with people, is by using slang words, or we short words up. So for example, I mean, I have been very amazed after moving to Australia that Australians love to shorten up every single word that you can. I mean, everything is breezy. Instead of McDonald's is Maccers. What else? I mean, there are so many. And I mean, I've been baffled by this, that you guys showed everything. So anyway, so we adopt idioms, and we adopt customs, cultural customs, to communicate with people. Well, programming languages are not that different. A programming language has different sets of abstraction that are not ingrained in the language, but have been developed by people in the language. And because of this, we have to import them into our integrated development environment when we want to use them. We will learn what those are. If you remember earlier, I mentioned that we will be using a package called Altair to create data visualizations today. So what does that mean? That means that that package was built by people to use this particular functionality inside Python, and we have to put it into Python in a second. So we're going to learn what that is, and then a couple of things, key things that you need to know about Python. Python manipulates and uses data. Data in Python, or in any programming language, is called, so this is your 1 minute of programming language lingo, or short course. Any programming language uses a representation of, or an abstraction of, what we use in the real world. Sometimes it's very directly related. We use numbers, they use numbers. We use words, programming languages use words. They might represent it in a different way, but they use it essentially in the same way we use it. So in Python, these things, text is called a string. Integers are the numbers that don't have a decimal place. Integer is a whole number, 1, 2, minus 1, minus 2, 0, 10, 11. No decimal place. A float is a number with a decimal place in it. It could be 10.0, that is a float. 10.5, that is a float. 20.2, that is a float. Dates are just dates. So representation of time, either yesterday, today, not necessarily in those terms, but the actual date, October 19th at 6 p.m. October 18th at 5 p.m. So those are date representations. Now, Booleans. Have anyone ever heard of Booleans here? Have anyone ever heard about what a Boolean is? Okay, quite a few people. Pause. Okay, so a Boolean is the evaluation of a statement. So what is the evaluation of a statement? I use glasses. True. That is a Boolean. I have a watch with me. That is true. Now, how are Booleans used most of the times in a programming language? They are used in something called if-else statements, or if-then statements, which are also considered something that is called control flow. Let me give you the best example of control flow. If today rains, I take my umbrella. If not, I leave it at home and I walk out without an umbrella. So think about what I just said. If it rains today, if that statement is true and it's going to rain today, I grab my umbrella. Otherwise, if that statement is false, it's not going to rain today, I don't take my umbrella. So that is a Boolean, the evaluation of a statement. So those are the ways in which Python represents data inside of it. That is what it gets fed into, that is what it gets fed, and what it outputs is whatever you want to do with that data. Now, it has something else. So how does it hold that data? Well, it holds the data inside data structures. So data structures can be many. There are tons and tons of data structures in Python. As a matter of fact, it's so hackable that you can create your own data structures. But the ones that we're going to be using today are two. One is called a data frame. I want you to think of a data frame as an Excel spreadsheet, exactly an Excel spreadsheet, but inside Python. is going to have rows with numbers in them, and it's going to have columns with names in them. It is exactly that. Every column holds the same value, and every row holds the same value. A series or an array is the same thing as a list. It's the same thing as a column in Excel. It's the same thing as a row in Excel. What is the difference between the two? A column has the same data type. So if it has strings, it has strings. If it has integers, it has integers. If it has floats, it has floats. That's it. That's a column. But it is a list. It's the same thing you will see in Excel. So think about if you go to Excel and you write 1, 2, 3, 4, 5, 6, 7 in the same column but different rows, and then you write 7 as a word as opposed to 7 as a number, and then you write 8, 9, 10, and then the next thing you know, if you try to do a sum, it's not going to work because you have different values. Actually, I really want to show that because it is so important. So let's do that very quickly so that everybody can see what I mean by the, okay, awesome. So let's move Excel over here. All right, so we are in Excel, and I want you to think of the data frame that we're going to be using in Python as this exact same thing. We have rows and we have columns. Those columns have names, those rows have numbers. In Excel, and then an array or a series is the same thing as a list. In a column, I always want to have the same data type. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I cannot. If you have used Excel before, you know that there is a very convenient function called sum. And if you use sum, and I grab this list of numbers, this list of values, what do you think is going to happen? And that is not a trick question. What do you think is going to happen? Invalid, error, exactly. I am going to get an error, or, well, in this case, it actually didn't. It actually just skipped the 7. So notice what happened. So I didn't know this. I think this is the new package of Excel, but I thought I had the same intuition as you. So let's actually check whether it skipped the value that was a 7. By summing up everything but the 7. So notice that it skipped the 7. So of course, it's not going to take it. What will happen in Python is that this, and I am very confident that in previous versions, this would have thrown an error, but of course it didn't here. Maybe if I create a table, it will actually throw an error. Well, it didn't, so never mind. All right, so in Python, this will automatically give you an error. So we gotta be very cautious with that. We want to have the exact same value in a row, the exact same value in a column. I'm actually going to leave my Excel open because I'm probably going to come back and do use some analogies with Excel. Now, if you are with me right now, I want you to go over these examples with me. So I want you to type your name inside quotation marks in the cell below and press Shift Enter. The quotation marks have to be the same, either double or single. Now, another thing is, if you press quotation marks, either one time or just one time, Python will give you 2 and we'll put the cursor inside the 2, which is exactly what you need. So I am going to put Ramon, and then I'm going to press Shift Enter. And remember, if this didn't, it might take a second for it to run, but if this didn't run for you, or if your Python environment, closed out, then make sure you go back and you refresh it. So this is quite interesting for me. It is not running yet, so I'm going to switch to this one and do the same here. So I'm going to type Ramon, and now notice that now I'm typing it with single quotation marks. I'm going to press Shift Enter, and notice what happens. The first value is my name. It just gets printed out underneath the cell. And what happens here? Well, I have a 1. 1 is the first cell that we have run in Jupyter, and 1 is the first output corresponding to the first input. So the input is the name, is the string, and the output is the string Ramon. Now, how do we add new cells? How do we run cells? So if I come to the plus sign over here at the top, I can add a new cell right underneath the one that says Ramon. And then I can put my last name, and I can say Perez. And I can click Shift Enter, and notice what happens. It knows and it understands that this is the second cell that has been run in this session. So because this is the second cell, the second output matches that second cell. All right, so in the example 2, I want you to type in the cell below, I want you to type the word name, no quotation marks. Next to name, oops, I want you to put an equal sign. Right next to that equal sign, I want you to put your name. And I'm going to put Ramon. And now I want you to press Shift Enter. Notice what happened. Let me see if this came back up. No, it's still working. I don't know why. Maybe I just need to refresh it. All right. So notice that nothing happened to the name Ramon. So if I go ahead and click sorry, I actually shouldn't have done that because I used a shortcut, so I'm cheating. So if I go to the plus sign and I add a new cell below name equals Ramon, I can either put name and press Shift Enter, and now the name is considered what is called a container or a variable. That is considered a variable in programming language. A variable holds a representation of data or a representation of an object or a representation of whatever we want to use. In this case, the variable name holds Ramon, holds my name, or it holds your name right now. Now, in example 3, what we're gonna do is put the equal sign next to it, type the name inside the quotation. So I think I put this one, example 2, example 3. I think I put this cell below with the word name. Okay, I think I meant to put in this one, type your last name, and I copy and pasted this too. So put last name all equal. So in Python, a variable cannot have spaces, it cannot start with numbers, and it can only have words, numbers, or sorry, letters, numbers, and underscores. That's it. That's all it can have. So I'm going to put last name, last underscore name, and then I'm going to put Perez. Oops, I need to put that in quotation marks. Remember, every string, so the reason, and I should have explained this here a second ago, every string, every representation of a string has to be inside quotation marks. Remember, it has to be either double quotation marks at the beginning and at the end, or single quotation marks at the beginning and at the end. Now, instead of pressing Shift Enter, we're going to press Alt Enter. And that's going to give us a new cell right underneath the one in which we executed code. Now we're going to use what is called a Python function. A Python function is a statement that is wrapped with parentheses, or sorry, at the end of the statement, you wrap something in parentheses, and inside that parentheses, you put whatever the function does. So in my case, I'm going to use and this is what I want you to do as well. I want you to type print. Another thing in which you can notice whether something is a function or not is because when you write it, if it's a Python function, it's going to be shining in green. Now, that green or that shining in green, you're going to pass in your last name inside of that. So I'm going to put last underscore name, and notice what happens. Perez comes up printed. So I got disconnected from it. Yeah, if you get disconnected from it, Natalie, refresh it. Just refresh it and then go back to the session. Let's see. Oh, there you go. So now I'm going to stay in binder. So in the second one, we created name, And then we put it equal to your name. So I'm going to put Ramon, and I'm going to use Shift Enter. Let me zoom in 1. There you go. Actually, I zoom in quite a lot. In the next one, we're going to put your last name. I accidentally left name, but I wanted you to put your last name in this one. Last, oops, underscore, name, and put your last name, and put it in quotation marks. Now, in the next one, I want you to subtract 5 from 10. If I can spell and count. So that gives you 5. If you go back to the same cell, another thing that you can do, you can go back to the same cell and you can put 10 minus 3, and then you get 7. So Python works exactly, if not better, than a calculator because it allows you to do fancier things. All right. In the next one, add 9 to 5 in the cell below. So I'm going to do 9 plus 5, just like you would do in a calculator. And that gives you, oops, and I went a little bit too far, that gives you 14. Let me zoom out just a bit. There you go. All right, that was our crash course to Python. Now, our project for the evening. What are we going to do today? So, in the, what I thought I would like people to get started before, so a lot of people like to get started with, oh, I want to tackle a real business problem. I want to tackle this, and that. I want to, you know, I want to cure hunger. But one of the main things that you need to be able to do any analysis with that is to start not necessarily from the basics, if you already know the basics of programming, but if you don't know the basics of programming, you actually need to learn some concepts to be productive using a programming language. And one of the best ways to get started with programming languages is to analyze something that is useful to you or something that is very unique to you. In my case, I like to work out. So I thought, well, how about I analyze the data from my watch? So I wear a Garmin watch. I forgot the model. I've been wearing it for the last 4 years. And I have a few data points on it, mostly of when I do outdoor exercises. And so I thought, okay, so I want to learn more about my working out habits, and I have a set of specific questions that I want to tackle. So my project is to learn more about my workout habits. So the other thing that I want you to take note from this is that if you want to do the same analysis and you take this code with you, you have a template on how to work with your own data. So if you have a smartwatch or a smartphone, I would highly encourage you to come back to this, get your data, and try to run the code with your data. So, all right, so now that we have the problem definition, this is me after day one. I actually put a case, sort of like our case study for today. So say you've always exercised at least 5 days per week, or that since last year, your New Year's resolution was to exercise for at least 5 days a week throughout the entire year. This being a completely novel endeavor for you, something no one else picks during New Year's. I mean, no one says I'm gonna work out a lot this year. You decide it will be a good idea to also track your progress throughout the year to understand what your workout habits, your routines, and your habits look like throughout the year. So you also want to come up with a few hypotheses, you want to come up with a few questions, and you want to interrogate them, or you want to analyze them visually. You want to create visual representations of the data that you have collected while you have been working out. Remember, it was your New Year's resolution. All right, so this was me on day one. This was me on day 2 in the struggle since I got this watch. So the data we'll use. I got this data from my Garmin watch I mentioned. So in the data analytics cycle, you have several steps. I didn't put them in here today because our main goal today is to learn about data visualizations and how to ask questions out of the data we have. So the data visualization cycle or the data analytics cycle goes like this. You have a question, or you have a problem, you have something that you want to solve, you have something that intrigues you. Then once you define what that is, you go and find the data that you need. I want to understand my workout habits. I got a Garmin watch. The data lives in my Garmin watch, so I'm going to grab it from there. So I put a little description. If you have a Garmin watch, follow them. and you will get to the bottom of your data, and you will be able to export it in a comma-separated value format. What is a comma-separated value format? It is a textual representation of information. So comma-separated values. Every single piece of information is separated by a comma. So if we have name, comma, last name, comma, age, comma, year, comma, and so forth. So a comma-separated value is a textual way of holding information or saving information. And that is what Garmin gives you. All right, so now that we know our problem, now that we have our data, remember, I have cut some steps because the goal of this session is to visualize data. But usually before visualization and after problem definition, and after problem definition and data gathering, you usually go through a very grueling stage, well, depending on the data and how you got it. You go through a stage of data cleaning and data processing. That stage can be very lengthy or it can be very short. Garmin actually gives you a very nice representation of data. So it's actually fairly just a couple of lines of code to clean it. And as a matter of fact, it might even be easier to clean it in Excel than it is to just by visually looking at the cells that don't match and that don't hold any information, than to gloss over them with code. But it might be, it depends on your preference. So Garmin is where the data that we're going to use today comes from. It should be already loaded in your session. So earlier I mentioned, so if you come to this cell that says import pandas as PD, I want you to press Shift Enter on that cell until it runs, until you see the 7 or whatever number is on the left-hand side for you. So earlier I mentioned that we create new representation of words to communicate with our loved ones or with people that are from our same culture. My first language is Spanish, and we have a culture of talking with memes to other people. So that is probably the representation we use to communicate a lot of information. You will be amazed at how much information you can pack into a meme. So anyhow, Python uses different packages that have been produced or created by people like me, like you, organizations, and they put it out there in a place called PyPy or Python Package Index. Once something is in that package, it's only a matter of a line of code to get that package into your computer. It usually weighs about a couple of megabytes in size, sometimes not even that. And Pandas and Altair are the two main packages that we are going to use today. What happens is that Pandas is a lengthy word, and because we are in Australia, no, that's actually, I'm joking with that. We're going to abbreviate it. Usually people in the data science and data analytics community abbreviate words by from packages that they import into their session. So right now, we're following the prompt. We're saying import this package that we're going to use and give it the nickname of PD. So import, this is the name of my package, Pandas. It is what contains the data frame or the Excel looking like thing that we're going to use tonight. We're going to import it with the alias of PD, and then we're going to import Altair is the package that we're going to use for data visualization this evening. So Altair, we're going to import it as ALT. Now, this option, you shouldn't worry much about this option, but what it does is that if you have too many columns in a spreadsheet, for example, here I can only see A, B, C, D, E, F, G, and that's it, all the way up to K. And but I can definitely scroll to the right and continue seeing different columns. If I go back to Python and I don't say that I want the max columns, I don't want any limit, I don't want any limit in the columns, then it's just not going to show me. It's going to abbreviate the columns and it's going to show me the first 5 and the last 5. So that's the only reason that line of code is there. All right, so now how do we read data? Well, we're going to read data into a data frame, and it's going to be called, and we're going to name it, we're going to assign it to a variable. We learned that a variable is a container. A container is something that holds data, holds information in your session while you're using Python. So Pandas has a very convenient way of allowing us to read and import the data that we need from a CSV file. So this CSV file is already loaded in the session that you're in, or sorry, is in the environment that your notebook is in. And all we need to do to read it is to run this function. So now our data is in our session. And the next thing we're going to do is we're going to examine it. How do we examine it? Well, Pandas has a very convenient function that is called head. Head gives us the first 5 items by default of the data frame. So if you press Shift Enter, what does this looks to me, and I'm sure it probably looks to you as well, the exact same thing like as a spreadsheet, as an Excel spreadsheet. Oops, where am I going? I hit too many. All right, so let's go back up. Okay, so that looks exactly like a spreadsheet. Let's see if I have any questions here. Working again, yeah, my work. Working again, managed to catch up. Okay, awesome. Everybody's good. Okay, so if I want to see more rows of my data set, I can put inside the parentheses or round brackets, I can put 10, and then it will show me 10 rows. I can put, and notice one thing though, in Excel, your rows start from 1 all the way to, I think it is 2.4 million rows that you're allowed to use in Excel, and not very well, not very efficient. But yeah, that's, I think, the max, 2.4 million rows. In Python, I mean, it doesn't really have a max, but it starts from 0 as opposed to 1. So right now, from 0 to 9, we have 10 rows. If I want just 7 rows or 100 rows, I can put that there as well. There you go. Okay, so in the example, I want you to try to use the tail method on our variable df. df stands for, uniquely enough, data frame, because we have a data frame. That is what we think of the data frame. Just think about the data frame is my spreadsheet. The data frame has cells, has columns, and has rows. And I am going to be using all of the data that is in cells, columns, and rows. So I want you to type df, that tail, and then put the parentheses and press Shift Enter. Also, another thing that you should know, if you don't want to press Shift Enter, you can also go to the cell that you have and you can click on Run here. So let me give you an example. I'm going to put tail gives you, what tail gives you is the end of the data frame. So instead of, so head gives you the top 5, the top 10, the top 15. Tail gives you the last 5, the last 10, the last 15. So if I want to put tail that 20, then I'm going to have from the very last one all up to the 20th in line from last. So I'm going to delete that, and I'm just going to leave it with 5 because that's fine for me. So that's what I want you to do there. All right. So now that we have our df tail, the next thing we're going to do is we're going to start asking questions, and we're going to start visualizing them, and we're going to start making sense of the data that we have. Remember, this data is mine, but I want you to come back to this notebook, to this Jupyter notebook, and put your own data in it. So today, you might end up knowing a thing or two about me. For example, that I lived in Kansas City, that I lived in Washington, D.C., that I lived in Santiago of Dominican Republic, and that I live here now. So those are the things that are going to be there. This is actually my data from my watch. And this is how I would envision somebody getting started with data analytics, with a project that is unique to yourself, as opposed to going and trying to cure hunger from the very first day of doing data analytics, or trying to solve a business problem without any either domain expertise or knowledge of Python. You have to start with something that is not going to hurt anybody, that is not going to make any decision for anybody other than to yourself. So this is going to make decisions for me, and I hope it does it for you as well when you bring in your new data. Your data from your watch or from your smartphone. Okay, so the first question, regardless of the year, what is the average amount of calories that I tend to burn per month? Things to keep in mind. We need a measure of calories in a numerical format. We need a measure of time in terms of months. What do we have here? Let's go back up. We have calories here, 608, 575. This is a hell of a workout. We have, towards the very end, we have the variable or the column in our Excel spreadsheet. Remember, think of the data frame as a spreadsheet. We have the variable month. So then we have month 10, month 9, and whatnot. All right, so the first thing is, can anybody tell me what are the 3 things that we need to create a data visualization? Can anyone tell me? Can anyone remembers what I mentioned earlier? What do we need to create a data visualization? We need layers, yes. What else do we need? What do we have? What do I have in front of me? So we need data, layers, and encoding. Yes, awesome, fantastic. That's exactly what we need. We need data, layers, and encoding. So first off, remember how we call pandas to call PD to be able to read in the data and assign it to our variable df, data frame. We can use alter, ALT, to create a chart. That chart is going to hold our data. Our data is the data frame, right? Our data is going to be represented, the columns that we want are going to be represented as a line. So I'm saying here, mark them, what I want, mark it as a line. The third thing that I mentioned at the very beginning of this session was, you need the data, you need a marker, how are you gonna represent the data that you want, and you need an encoding from the data to the visual elements of the chart. So here we are saying, encode in a line, the months, in the X variable. Remember, think about high school math, X and Y coordinates. So we're gonna have in the X coordinate, we're gonna have the months. Remember earlier in the do's and don'ts, when you're gonna show a line trend, you should show something that is using months, that are using time. Don't show a line if you're moving from, I don't know, electronic products at the supermarket to food and beverages categories. That doesn't really represent anything. And then in the y-axis, we're gonna have the calories. So every month and every calorie is gonna be mapped to each other as a line. So we're gonna see something in a line. Now let's run this one. Okay, can anybody tell me what is the problem with this graph? What is the issue with this graph? Confusing visually, yes, absolutely. What else might you notice in this graph that is it just doesn't feel right? Range in the months, perfectly, awesome. That's exactly what I wanted you to notice. When we represent data in a chart, in a visual display, we are usually trying to show it in an aggregated way. If we don't show it in an aggregated way and we just partition it by a specific category, a specific condition, we're gonna get something a little bit messy depending on how we did it. So think about it this way. In month one, this all makes sense because I didn't aggregate anything. Remember my question back up, what is the average amount of calories? If you think about it, I have a column. Remember, this is my data frame. This is my variable up here. And I have a column called calories. And I pass the column called calories to the x-axis. And I pass the to the y-axis. And I pass the month variable or column to the x-axis. But what happens is that I want the average. So this is plotting every single value for the month of January, for the month of February, for the month of March, for the month of April, and so forth. So it is not showing what I want in reality. So now let's run the second one. In the second one, you're gonna see, if you recall a second ago, I mentioned that in Python, functions are wrapped around a parentheses. Functions that are innate, that are original to Python, that they come with your session. You open up Python, you have that function available. Alter has functions and has functionalities like chart, like mark line, like encode, that we have to import by doing an import alter as ALT. In this case, we use mean, we wrap it around our column calories, and now we have a different representation of data. So now, this is a much better looking chart, but still not great. It's still not that good of a chart. And the reason is because I can see exactly what the average calories, what the average amount of calories I burn per month is. I can see it, but I cannot really tell. I can tell that this one is exactly 200 in February. In 200, on a daily basis, I burn about 200 calories. on my workouts. Here, I am not sure if this is 225 or 224 or so forth. I'm actually kind of confused because I can't. So what I could add is a little tooltip. What is a tooltip? A tooltip is, imagine you go to the New York Times or you go to any other kind of visual outlet that post a bunch of data visualizations on the daily. For example, the BBC. I know they have or The Guardian. The Guardian has a fantastic data visualization team. And they just put out hundreds of visualizations every month. So a tooltip is an element inside a chart that allows you to hover over the line and look at the value that your mouse is pointing at. And that's exactly what we're going to do. We're going to add, so here we added in the Y, we told Python, give me the mean of every month of the calories in every month. And here we're going to say, but also let me point to every one of those months with my mouse and let me look at the calories. And also we added every charts can have properties. If you recall in the do's of our session at the very beginning, if you recall, we talked about charts should have a title. Charts, and it's not mandatory if you're doing it for your own purposes. Like if I'm just visualizing for myself, nobody's ever going to see these charts. Be my guest. Do whatever you want to do with your charts. But in this case, I'm showing you how you can do that in Python. You can add a property to a chart that is going to be called title. All right. So now we're going to run this one, Shift Enter. And now, if you hover over the points, now I see that the exact value. You see, I would have never been able to guess that I burned 284 calories on average on the month of October. October. It's the month in which I am most active in the last 4 years. And so that's pretty cool. So that's something that I didn't know. So answer, it seems that October is the month of the year where I burned the most amount of calories with 284.81 on average per day. Hell yeah. All right, so let's untangle what just happened. Data. And a way to so a chart is a layer representation of information. I'm going to repeat what I talked about at the very beginning when we were talking about what data visualization is. A chart is a layer representation of information where we need data and a way to represent the information that we want to visualize from the data and a way to encode what we are interested in to the elements in the chart. What we're interested in the data to the elements in the chart. So remember, with a chart holds the data, mark gives us an encoding, a marker or some way of representing what we want. The encoding map those elements to one another. All right, in other words, ALT is the abbreviation of the name of the Python package we are using to create the visualization. And from it, we can create a chart object to which we get to pass our variable containing our data called df. Remember, it's a container. To represent the data we want to use, mark line, to represent the data we want, we use mark line, which helps us visualize our data of interest as a line instead of a circle, square, and whatnot. We then encode the information we're interested in into X as the months and Y, the average amount of calories, coordinates. Lastly, our chart needs properties such as title to convey the appropriate message. All right. Anything clear? Does anybody have any questions for me? We just learned how to create data visualizations in Python in just a few lines of code. And I know there's a lot that needs to be unpacked, and there's a lot of things that might be sort of in the air, and you're like, okay, so how does this work? How does that work? But it really, if you have the data, if you have the package, you don't need more than that, than an integrated development environment to start creating these charts. That is true. That is a fact. So any questions for me, please shoot them on the chat and let's continue. All right, example 2. Are the kilometers I run correlated with the amount of calories I burn? I would assume they are, but things to keep in mind. We need 2 quantitative measures. They don't need to be in the same scale, think kilometers versus miles, Fahrenheit to Celsius, but sometimes that is very helpful. We can plot let me give you an example before I jump in from that second one, because I think that one is very, very important. A scale matters, and different measurements sometimes might make or break a visualization, or a data analysis. For example, if you're using Airbnb data, and in that Airbnb data, you have listings from different countries. You start calculating the average amount that it will cost you, the average amount of money that it will cost you to stay at the 5 top places that you have picked. What you don't notice, or what you don't take into account, is that those 5 places are at different countries, and that the data that you have for the prices of those listings are actually in different currencies. So if you get the mean of 10,000 yen, 50 Australian dollars, 100 US dollars, 70 British pounds, and then you take the average of those things, it's going to make no sense. It's going to make absolutely no sense. So that's what it means. Sometimes it's very important when you're correlating two things to put the same two things in the same scale. So with that in mind, we can plot quantitative variables using points or circles. The type of visualization that represents is called a scatter plot. A scatter plot, I put the definition here from Wikipedia. A scatter plot is a type of plot or mathematical diagram using Cartesian coordinates to display values for typically 2 variables. Cartesian meaning the X and Y coordinate, what we saw in high school, all of us. All right, so let's talk about the chart. So we have, again, we're using Altair. We're calling the function chart, and we are passing in our data. We need an encoding for that data. We need a way to represent that data. We need a marker. That marker is going to be a point to create a scatter plot. Then we need to encode those points to the elements in our data, those points in the chart to the elements in our data. So the X is going to be the distance that I ran, or the distance that I worked out, because I also have cycling, running, and running. No, I have elliptical as well. And then Y calories. So how many calories did I burn by the distance that I worked at? Okay, and here's the night representation. I'm sure all of you, have any of you never seen a scatter plot before? Have any of you never seen this visual representation before? Something in the x-axis, something in the y-axis, and there's a mapping. Okay, Goran had never seen it. So Goran, this is a scatter plot, and a scatter plot takes the values at calories. So for example, if here I have 500, and here I have 400, for example, and then here there's a little point here, that point maps to kilometers, 4.5 kilometers. So for example, this little point over here at the very top says, in this workout, I burned 750 calories and I ran 9.5 kilometers. So that is what a scatter plot is doing. It's mapping one value to another value in 2 axes in a 2-dimensional way. Okay, it's gonna make more sense here in a second. But to amuse ourselves, answer, indeed, you would assume that the more you run, the more calories you burn. I cannot imagine how that wouldn't work in that way. But yes, we would expect to see those two things correlated. And I love this cat that I found. I told you that we use, from back at home, we use a lot of memes to communicate information. So I'm trying to put that in here into this lesson as well. Okay, so what is correlation anyways? In statistics, correlation is the degree to which 2 or more, as a matter of fact, that is too technical definition. 2 things, I have 2 things. Those 2 things move in the same way, they are positively correlated. 2 things move in different ways, they are negatively correlated. One thing moves up, another thing moves down, then those 2 things are not correlated at all. So let me give you an example. What will happen, what will be the correlation of the weather getting hotter and ice cream sales increasing? Would it be positive or negative? Can anybody tell me? It will be positive. Exactly. If it gets hotter and you start seeing a trend that ice cream sales are going up, it's probably because people enjoy ice cream. But if you were to say what's happening to the sales of hot chocolate as the weather is getting hotter and hotter, you will probably see a negative pattern. You will see those 2 things moving in opposite directions, unless it of course depends on what part of the world you live in. but I would assume that if it's in a normal place that it gets very, very hot in the summer, very, very cold in the winter, then you would expect to see the sales of hot chocolate decrease in the summer and then increase in the winter. That's just speculation, of course. One doesn't necessarily cause the other, but what I'm trying to allude to this is that the movement of two things might move in the same direction or in opposite directions, and that is called correlation. All right, so let's go to example 3. Can we explore the calories versus distance further? More specifically, can we zoom in into the most productive workouts days, the most productive workouts? Can we split all workouts by the time of day in which they occur? So things to keep in mind. To answer these questions, I got a little typo there, these questions, we could take advantage of interactivity in our charts to change the story as we go. In addition, we will need to split our quantitative variables and categorical variables. If you recall from the table above, categorical variables can be nominal. The order, no order is implied. Table, chair, male, females. Or ordinal, order matters, hot, mild, cold. All right, so for example, yeah, I put the same examples here, but so let's do that. Let's go ahead and call alter again, pass in the data into our chart, add the marker that we're going to use to represent the data, and encode one to the other. Now, notice the last piece here, the dot interactive method that we have added at the very end. What does that do for us? Well, if we want to zoom in and see what is happening, you can use, so it's kind of tricky because I'm using the trackpad. So try to, if you're on a laptop, try to use the trackpad. If you are on a you're using a regular mouse, you might want to, what would it be? Control and the scroller, I think it is. But yeah, I'm using the mouse, the trackpad to zoom in. And I can see that by adding interactivity, I can get even closer to the data and what it represents. So Goran, earlier you asked, okay, what is a scatter plot? So if you see this point here, it pretty much represents 760 calories burned up to 8 kilometers, a little bit above 8 kilometers run. The scroll wheel, yes, the scroll wheel, perfect. And you can also grab it, you can also click on it and then move it to the side, to the left or to the bottom, and then you can explore the data further. All right, so that's good and well. Now, let's add interactivity and then let's add the categorical variable. Remember that we mentioned that we want to split the workout by the time of the day in which it occurred. I split the time of day in which it occurred. If you're wondering, how is this split? When you see the definitions of those. So I'm gonna click on this chart, on the chart, and then on the chart, if you click on the chart, click on the plus button at the top. And then in the plus button at the top is gonna give you a new cell. In that cell, let's type again, df.head to observe the first 5 rows of our data frame, of our Excel spreadsheet, if you recall from earlier, just in case we forgot what kind of information that we have. So remember, we have activity type, time, calories, a bunch of stuff, number of laps, number of runs, month, year, whatever. And we also have time of day. We also have a variable or a column called time day. And it says afternoon, night, afternoon. There's also another one saying morning. So what does that mean? What that means is that what I picked was 5 a.m. to noon as the morning, noon to 6 p.m. afternoon, and 6 p.m. all the way to 5 a.m. in the morning as night. So that is what that is going to encode the variable. All right, so we now want to add the interactivity and a categorical variable. So we do the same, pass the distance to the x, the y to the calories, and then now we want to color code the points in our chart by the time of day. So that's going to split, and it's going to give us a color for the afternoon. It's going to give us a unique color for the night, and it's going to give us a unique color for the morning. And then we're going to add the interactivity element with the same method that we used in the previous cell, or 2 cells above, because we just ran another one. All right, so notice how pretty things are starting to look. So now we have Now we can zoom in and we can see what the heck happened. When did this workout happen? Well, it happened in the afternoon, the one where I ran the most. And then when did this one happen? Well, it happened at night. This one where I burned almost 700 calories and ran about 7 kilometers. Also, another thing about my data, because I moved here from the US, I had it in miles, so I had to convert it into kilometers because I know here you use kilometers, so that was very fun. Also, the Celsius, I didn't have temperature, I didn't have it in Celsius, but I had it in Fahrenheit. And then I had to go back to when they taught me in high school, how do you convert Fahrenheit to Celsius? Maybe a lot of you remember, I couldn't remember. So I had to do that when I was working on this session. All right, so the last bit. So it's not just useful to be able to look at this and say, okay, this one was in the afternoon, this one was in the evening, this one was in the morning. You can very much tell that I'm not the biggest morning person. And if I do, it's very, very short. It's a very short run, what I do. So don't judge me. All right, so in the next one, we use color again as the time of day, for the time of day. But now in the tooltip, we want to see a couple of things. Remember that the tooltip was the first thing we used in our third cell after we started visualizing our data, where we could see that calories burned in the month of October was 283 or 281. So the tooltip now, we're going to pass different columns. So if we land on a point, that point is going to show us the distance, it's going to show us the activity type, and it's going to show us the time of day. It's not only going to do that, but it's also going to show us the calories that are mapped to that. We're going to add a title, again, using the properties method, calories burned versus distance by time of day. And then we're going to add the element that we did earlier called interactivity. I'm going to press Shift Enter here. And now let's examine what happened. Let's see, I think I have a question here. Okay. All right, so yes, Liz, we will wrap up very quickly. We have about 5 more questions. And we're gonna try to do them a little bit faster. Okay, so now we can see how many calories exactly, what was the distance, what was the activity type, and what was the time of day in which we ran. Let me see, do I have another one? All right, cool. So we'll do the next ones quite fast because we don't want to take that much of your time. This is a 2-hour tutorial. We have about 25 minutes left. I would say it should be about 10 more minutes to finish. So in the next one, let's go to the next example. By the way, the answer to the last one, by splitting the data by the categorical variable time of day or time day, we were able to separate the distance run by the time of the day in which the workout occurred. So this allows us to figure out that the workouts in which the most calories were burned were in the afternoon, followed by the evening. All right, example 4. Let's make things a bit more interesting. What is the relationship between calories, distance, and calories and temperature? Also, it will be great to see the temperature split by the buckets, hot, normal, cold. I put hot twice. It was meant to be cold. Things to keep in mind. We can also concatenate charts that share an axis, meaning if the same calories is going to be in the y-axis and we're going to have 2 charts, they might as well use the same one. We can also use, out of our x-axis, our x-axis will contain our 2 other quantitative variables. We will need to split our variables by categorical variables again. All right, so let's now create a new variable called interval to allow the interactivity between the 2. We're going to create a color scale for our mapping, and we're going to create another tooltip, and we're going to use new representations from Altair, conditions. We're going to add an interval to the color that we're using for this chart. We're going to press that one, and then at the very end, the way in which you combine charts using Altair is by the pipe operator. So this little pipe here in the middle, we use calories. Now it should be coming up soon. There you go. So now we have 3 things that are nice to see. I can see the temperature. So above, so the way I made the cutoffs, you can see that cold is less than 14 degrees Celsius. Normal is between 14 and 23 Celsius, and hot is greater than 23 Celsius. Now, the cool thing about this new chart is that now we can pan in and check out the values inside, and they will both move along with each other. So notice that even though I see that the temperature was low. That doesn't mean I didn't burn a lot of calories in that workout. That doesn't mean you will once you put your data in here. Now, if I go all the way to the top and I see that there's only a few days below 14 degrees that I will actually go outside. And so anyways, this is really cool. This allows us to see and extract information that probably you would never know. If you start to think, when did I work out the most last year or 2 years ago? Then you'll be like, okay, I cannot remember. To be honest, I cannot remember. So these are ways in which you can find things about yourself and about your patterns and about your habits without really having to keep a journal or something. Let a smartphone or a smartwatch take it for you and then analyze the data later on. An answer. So a quick glance at the data tells us that the workouts tend to happen mostly during hot days with very few instances happening below 15 degrees Celsius. In addition, longest distance we run, the most amount of calories burned happen at 23 Celsius. So we can also see that the amount of workouts and also their intensity diminish significantly above 30 degrees Celsius. But either way, my favorite workout weather was, as you can see in the chart, was hot days. So my favorite workout weather would be like today's forecast. All right, so example 5, we have about 2 more examples. What does the frequency of my workouts look like by the day of the week? Let's run that chart, Shift Enter if you recall. Now we can see our very familiar bar chart. We can see that in the last 4 years, I've worked out on Thursdays the most, about 100 times in the last 4 years. And then the rest have sort of an even distribution. Answer, it seems that my workouts take place on Thursdays and followed by Mondays. You know what they say on Thursdays? Thirsty Thursday, cheers to not waiting for the weekend. All right, so in the next one, what happens? We have about 2 more charts. What happens to my average heart rate as I run further and further? Better yet, can I view this alongside the frequency of workouts between the different times of the day at which I work out? So I know there was a lot of things there. So let's keep in mind a couple of things. We need a mix of variables in different charts concatenated with each other. We need the average heart rate, and we also need the distance, how much I ran, and also the different times of the day. So we need to connect them with filters. So here we are creating a variable called chart. We are passing the same interval that allows us to use some interactivity in our chart. Then we are creating another one, because remember, we are concatenating 2 charts. This different chart is called a bar, marked bar, and then the one above is marked point. So remember, scatter plots and bars. Bars is the one that we just did up here. And we are transforming that, and we are connecting them with a AND. All right, so let's see what that gives us. So look at this thing. This is very nice. I can see the afternoon, I can see the morning, I can see the night, but better yet, I have some interactivity. So notice what is happening. If I move up here, the bar at the bottom changes. If I notice that the blue is almost never below the red. So the workouts in the evenings are always, or almost always, less than the workouts in the afternoon. Except for here, in this little patch of time, so between running 2.5 kilometers and running 4.5 kilometers, that's the only amount of times where the times where I worked out at night surpasses the time that I work out in the afternoon. All right, so that's very cool. Nightly workouts only surpasses the afternoon, only a small amount of, in a small interval of time. That's fine. So last 2 more questions, and the last one. Where have I done the most, the least, and all in between kilometers during a workout? So things to keep in mind. We need the distribution. Where does a number fall? Where does the next one fall? Where does the next one fall in a chart? So let's run this chart. We have walked through some of the elements inside this chart. So this chart is called a box plot, or a box and whisker. The whiskers are the elements of a chart that gives you the 75th percentile of the amount of numbers that we have in that bucket. In this bucket down here, you can see Kansas City, Royal National Park running, that was here in Sydney, elliptical, indoor cycling, Kansas City running, and so forth. If you hover over, you can see the maximum distance, the third quarter, 6.82 kilometers, median distance, 4.83, 25th or Q1, 1.3, minimum distance, not even half a kilometer. That was a lame run. All right, so answer, Sydney is definitely pushing my limits, but Kansas City and Santiago have kept me going the longest. And if you see Sydney over here, you see that my furthest run, almost 10K, was actually here. All right, so very last chart before we wrap things up. So what does the distribution of my workouts look like when I split them by the quarter of the year in which each workout took place? Things to keep in mind. We need the distribution of a quantitative variable split by the quarter of the year in which the workout took place. So 4 quarters, first quarter, the first 3 months, second quarter, the next 3 months, and so forth. Let's run that one. We call the color quarter because we have a variable called quarter in our data. Notice the hue is the intensity of a color, or we can just call it intensity. So the intensity of the quarters go first quarter of the year is the light blue, then a darker blue, then a darker blue, then a darker blue. So this is a nice representation to see when your workouts have taken place. I really want you and encourage you to find your own data and put it in this notebook. Pass it in this notebook and start checking out what you do. What are your workouts? It doesn't even have to be workouts. It can be your patterns, the calories you burn on the steps you take daily. How many levels do you go up and down in a day? You can also put that in this notebook and start visualizing things yourself. So most of what I do, or track for that matter, is running, whether outside or on a treadmill. So that's it. All right, so this wraps up our short tutorial on data visualization. This was meant to get you started thinking about what a data visualization is. How does that happen in a coding environment? It's not a mysterious environment. It's not something that nobody can do. As a matter of fact, I think anybody can code. I actually firmly believe that, and I think everyone here at Coder believes that everybody can code. This is nothing that just have to have a specific type of people to do so. We didn't do a single piece of math, if you think about it. We did not do anything with math, and at the end of the day, we still analyze the data with things that are mathematical, like the mean, like the average, like the median, and so forth. So the next step, here's a non-exhaustive list of things to keep in mind when creating visualizations with data. Know your audience, identify your message, adapt the figure to support the medium. Captions are not optional. So always add as I mentioned at the very beginning, always add the elements to a chart. Do not trust the defaults of an application, of a tool. Remember that I went with the defaults in my very first chart, and we just saw something completely amiss. If we were to do that in Excel, Excel will know that we want to see the aggregation of the mean of something. So it would have given us that. So avoid chart don'ts, the don'ts that we went over at the very beginning. Get the right tool for the right job. So we have learned a lot today. Visualization is great for exploring our data sets. It allows us to see interesting patterns in the data. Static graphs are great for telling a story from one angle. Interactive visualizations are great for involving the audience with the message we are trying to convey. Python is an excellent tool for visualization, and Altair is just one. All right, to feed your curiosity, I have a bunch of links over here. Make sure you take advantage of it. These are some of my favorite data visualization designers. I lived in Kansas City for 3.5 years, and Edward Tofty is considered the main or one of the biggest figures in data visualization. He's actually from Kansas City. So for your next learning steps, please read these on. And at the end of the session tonight, if you could please provide me with some feedback on what you thought of the session so that the next one can be even better, I would really appreciate it. Thank you. Goran, I'm going to pass it, and Dallas, I'm going to pass it up to you now.
Cool. Thank you very much, Ramon. That was amazing. Let me just share my screen here.
Thank you very much, Shannon and Galvin and Anna.
Awesome. Cool. Thank you so much for that. That was really, really good. Very informative. Sorry to cut you a little bit short there. Basically, we'll just roll through a few things about the Intro to Python for Data Analysis short course, which is coming up on the 31st of October. It goes for 7 weeks, and it's on Saturdays and Tuesdays. So Saturday 9 a.m. to 5 p.m., Tuesdays 6 p.m. till 9 p.m. So that is Sydney and Melbourne time, if you're in Brisbane, it's going to be 8 till 4 on Saturday, and Tuesdays will be 5 till 8. Cool. Delivery 100% online, much like this was today, and you will get a certification at the end. There is no requirements, as you've just all discovered right here, right now, that, you know, like you can be taught from the ground up. You don't need to have any experience whatsoever. We'll teach you everything you need to know. And you can see here, the price is $1,999, but we do have a discount for 72 hours only of $1,699, okay? Valid until Friday, 23rd of October, 8 p.m. So make sure to get in on that one if that's what you're chasing. Let me just move some things around here. So weeks 1 and 2, you'll be learning the fundamentals of Python programming for data analytics and Jupyter notebooks. So it'll be good to get amongst that and learn a little bit more than what you've learned here today. Weeks 3 and 4, gather, clean, and prepare data for analysis. Consolidate data from multiple sources and visualize complex data. 5 and 6, statistics for data and analytics and data interpretation. And then week 7, real world immersion. Select, clean, prepare, and analyze a data set, evaluate your findings, and showcase your work. So you'll learn a little bit more about that in this slide, I believe. So power up your career, in-depth and intensive, the most comprehensive Python and data analysis online short course in Australia. Real world immersion. Complete a capstone project that takes you through the entire data analytics cycle. So essentially, if you're not sure what a capstone project is, you're pretty much gonna, is your assessment, your final assessment that sort of like gets you that certification. But in saying that, it's also something you can take with you into the real world. So you will be basically, I guess, like, you know, gathering and cleaning data sets yourself, you know, data that you found. Basically, you'll be building every piece of the puzzle and you'll have something to show to, you know, employers down the track. So gain industry access to industry experts, weekly speakers series to give you tips, insights, and trends from data pros. We'll talk more about those guys soon. And also, you know, you do get a free ACS membership that's included in the course and valued at $374. So course outcomes, you know, it basically gives you a good grounding to sort of break into data and become a data analyst. And $92,000 is the average salary. And the demand for analysts is up by 28% in 2020. So that's always good. These are a few of the speakers. I won't go through everyone. I'll just pick a few out because we're a little bit short on time. But we got Mike Dane here, Codecademy curriculum developer and educator. He's got 112,000 YouTube subscribers. He does some really cool stuff. So check out what Dane's got going on on YouTube and also listen to what he's got to say during the course. Dan Adler, PhD in machine learning and bioinformatics at Cornell Tech. And then we'll jump across to Victoria Sevsenko, assistant professor of strategy in INSEAD. And then what else? So this is another
a quick thing that I like to say. So I didn't mention that. So I actually work as a research associate as well at INSEAD. So if you can go back to the previous slide. So I am developing a package, a Python package with Ariana. I work with her. And then Victoria is my coworker at INSEAD, where I work as a research associate. And if you're interested to learn who taught me data analytics, well, that was Kelsey. So Kelsey was my first boss in my first analytics job, data analytics job at a consumer behavior firm. And she's absolutely mind-blowing. And like her genius to analyze data is just out of this world. So anyway, so just a quick talk of who all these people are.
Yeah, cool. No, awesome. Fantastic. And here is another mention of that discount, guys. So if you want, there's a QR code there. Get into it. And otherwise, I think maybe we might be able to put something into the chat as well, if Gorington has anything there available. So also, this is where you can go ahead and enroll. And go ahead and throw on, click, and I believe if you don't use this code here, the QR code, you can go ahead and just type in Python 15, all caps. And these guys are the enrollment team. So you've got Brendan Browner from Sydney, Goran you've got from Melbourne, and me from Brisbane. You can reach out to any of us about the short course coming up or about anything really. And yeah, you don't need to specifically contact one of us for the state specifically. We can all talk to you about all sorts of things. So yeah, feel free to go ahead and reach out. And if you guys have any questions, go ahead and, you know, throw them into the chat right now, or you can even give us a call or shoot us an email. And that's pretty much it. So does anyone have any questions at all? I'm just going to jump out of this view I've got going on because I can't see anything. Cool.
Thanks, everyone.
By the way, so now that we're wrapping up, if anyone, so actually, can I share my screen very quickly? So a couple of things for everyone. If you will like, you can keep the link. It's never going to disappear, that link that you have for that Python notebook. And you can also, can anyone see my screen?
Yeah.
Yeah.
Okay, cool. And you can also come to the top of the file that we just worked through, and you can click on File, and you can click Download As, and you can click Download as HTML. When you download it as an HTML file, what you're going to have is, you're going to have basically a little static website that if you double click on it, you take the lesson from today with you. So if you want to do that, do that. The pictures might not show, some of them will, most of them will, but some of them might not. But you can always keep the link and come back to this session. And when you have Python in your computer, you can download it as a regular file, as a regular Python file, which is a python.py or notebook, which is what we're using. So you can always have what you got from today. That's what I'm trying to say.
Cool. Awesome. Very cool. I'm definitely going to check it out later. Mine timed out, so I couldn't finish the end.
Yeah, so this will be was recorded and everyone will get it. So if you want to go through it again, follow along, do it over again, feel free to do it. As Ramon said, the link will be live and you can use it.
Cool. Any other questions at all?
Awesome. All right. Well, thank you, everyone.
Yeah.
It was a pleasure having you tonight. Thank you so much for sharing Tuesday evening with us. Have a great rest of your evening. Larissa, thank you for waking up so early for us. It's truly an honor.